The last concept we want to talk about in sets is that of partitions. A partition of a set is simply a way of breaking a set into pieces. That's it. So intuitively, it's a very simple notion. I'll give you an example. I can take a set of natural numbers and I can say it's even natural numbers and odd numbers. So the even numbers and the odd numbers are the partitions of the set of natural numbers. But to make it precise, we need a little bit of jargon. So first thing we need is disjointness. We say that sets S and T are disjoint if S intersection T is empty. So there is no element that belongs to both S and T. That's why disjoint. And in our example, there is no number which is both even and odd. So we can say that the even numbers, set of even numbers intersection the set of odd numbers is empty. So that's disjointness. Then we need pairwise disjointness. This applies when there are more than two sets. So suppose I have a collection of sets S1, S2, blah, 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 Sn. These are all sets and these are called pairwise disjoint if for any ij between 1 and n, Si intersection Sj is empty. So I have a collection of sets and pairwise disjoint simply means I pick any two of those and I take their intersection, I'll get nothing. So they are all disjoint from each other. And now I can define what a partition is very precisely for you. A partition of a set S is a collection of subsets a partition of a non-empty set S. We only define partitions for non-empty sets, otherwise it doesn't make much sense. Is a collection of subsets S1, S2, Sn such that each of these subsets are non-empty. They are pairwise disjoint. Non-empty simply means it's not the empty set, so it contains at least one element. And finally, I should recover the whole set back if I look at all of these together. So S is union of Si. That's it. So that is what a partition is, and I can pictorially draw it as, let me take this to be my S. Then when I have partition, I'm just breaking it into small globs. So I can say this is S1, S2, S3, S4, S5. They cover all of S and they don't overlap. Let's do another example. This set 1, 2, 3, and I can partition it as 1, union 2, union 3. That's one way of partitioning. I can also partition it as, so that's another example. Now a non-example, sorry, this is bad writing. I should have written it in a different page. A non-example would be if I try to do it like this. And this is not a partition because here we have an overlap. 2 and 3 are common to both the partitions. That's all there is to partitions. Later on, when we do combinatorics, we will see ways of counting the number of partitions of a set. But right now, we just need to know the definition.